angles games questions are those questions where you're given a bunch of angles, you're given a bunch of figures, and you have to find a missing angle. And there's certain rules, certain things to remember so that can help you fill in these angles. The first are our vertical angles, and we've referenced these a couple times previously. When you've got two lines intersecting at a point, the angles across from each other, called vertical angles, are congruent. So this purple one equals this purple one, and this green one equals this green one. The next type is supplementary angles. So when you have, again, a line intersecting another line, not only does this angle and this angle equal, and this angle and this angle equal, but when you add up the two angles that make up this side of the line or the other side of the line, these must add up to 180. Right? Just as purple and green would have to add up to 180. So too would blue and green have to add up to 180. So too would red and purple have to add up to 180. And those are called supplementary angles. Complementary angles, we've already talked about this when we talked about trig. If you recall, they're complementary angles add up to 90. So here I've got two angles splitting up this right angle, so of course they're going to have to add up to 90. How about parallel lines? We've mentioned this a little bit briefly, and I want to talk about it here. Let's say we've got two lines, L and M, which are parallel. And let's say they're being cut by this line, and we call this line a transversal. Just a line that cuts through. There's a whole vocabulary about alternate interior angles, alternate exterior angles, which you might know and you might be comfortable with. But I like thinking of it this way. These small angles, these acute angles, are equal to each other, not only because these two are vertical and therefore equal, but if you think about it, this transversal, as it cuts through these lines, it's going to hit the lines in the exact same way, no matter how many parallel lines we have. So this angle and this angle must be equal. This angle and this angle must be equal. Same thing with our big angles. This obtuse angle, obtuse angle, obtuse angle, obtuse angle. All of those angles must be equal for the same reason. So you can remember that each set of four angles has two pairs that are congruent, and that just moves all the way down. If you cared, you could also look at this as like, this angle 1 and angle 2, angle 1 and angle 1, those two are alternate exterior angles. Angle 2 and angle 2 are alternate interior angles. Angle 3 and angle 3 are corresponding angles, but frankly, that makes it, I think, more confusing. If you want to know that, you can. I just like realizing that, okay, this pattern is repeating. If I added another line, you would get the same set of angles. If I added this line, you get the same set of angles. As we've discussed previously with triangles, in an isosceles triangle, don't forget, these two angles must be the same, and of course, these three angles add up to 180. In an equilateral, these three angles are the same, and because they've got to add up to 180, they've each got to be 60. Let's look at some questions. So line L and M are parallel. What is the value of x? You cannot make this 40 because this does not have that line there, right? This is not the transversal situation which we saw here. It's a little bit different. You almost have like two lines, two different transversals meeting here. What you can do in this case is let's extend this line. When I extend this line, suddenly these green lines form that transversal situation such that all of these small angles must be equal. So we know that angle must be 40. Now here, this angle and this angle, they're supplementary. They're on the same line. They've got to add up to 180. So we know that's got to be 55. We know these three angles have got to add up to 180. So that adds up to 95. That must be 85. And now finally, these two angles must add up to 180. So that means x is going to end up being 95 degrees. And that would be our answer. So that one combines parallel lines. It combines sort of vertical angles. It combines supplementary angles, angles in a triangle. That's an angle game, right? Using all those rules to find a missing angle. Last question. In the figure above, AB and EF are parallel. AC equals AB. EC and EFG are congruent. FC and ED are congruent. What is the value of x? So let's fill in our info. We know that EF and AB are parallel. We marked that here. We know that EC and FG are congruent. ED and FC are congruent. And then we also know that this side equals this side. So if this side equals this side, these are isosceles at the very least. Well, no, must be isosceles. So that must be 50 because the base angles are equal. Notice what we have here. If these are parallel, actually already wrote it in here, this angle has got to be 50 because you've got two parallel lines cut by a transversal. Those two angles must be equal. You can either think of it as alternate interior angles, or you can see that these are the two acute, the two small angles. So if this is 50 and this is 50, this as well must be 50 for the same reason, because you've got a parallel line cut by a transversal. So if this equals this, then actually these two sides must be equal because it's isosceles. If these are equal, then these are equal. So these two must be isosceles. So this equals x, and then this must be x, and this must be x. Okay. If this is 50 and this is 50, this must be 80 because they've got to add up to 180. This is 80 because that's got to be vertical angle. These must all add up to 180, and you'll find then that each of these is 50, which means this is 50, which means these are 80. Long story short, you can fill in all your information, and you'll find that x is 50. And again, that's an angle game, using all of your knowledge of angle rules to find your final answer. One note about quadrilaterals, we haven't really seen many questions specifically on these beyond area, which I think is pretty straightforward. Definitely know how to use that formula. There are three major types of quadrilaterals to know. You've got the parallelogram. In the parallelogram, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. In a rectangle, all of the above is true with the additional information that all of these angles are right angles. And in a square, all of the above is true with the additional information that all the angles are equal. So if you looked at a square, all of the angles are equal, all of the sides are equal. In fact, all the angles are 90 degrees. All the sides are parallel, and yeah, there you go. Now, what about perimeter? Perimeter, we've looked at this a little bit previously. Just to note, perimeter is when you add up all the sides. So if I knew that this was a square with side 4, I would know all of these are 4, so therefore the perimeter is 16. Pretty straightforward. Okay, let's move on to the next video.